Alright, so today we're going to talk about solving systems by elimination. So elimination just means that you are going to eliminate one of the variables. So I've lined out the steps here. So the first thing we need to do is we need to line up the equations. So that means that the x's, the y's, and the numbers are all lined up and the equal sign is where it's supposed to be. Then we are going to multiply one or both of the equations by a number to result in a variable with the same coefficient and opposite sign. So a coefficient is the number in front of the variable. So in this example here, if I have 7y, the 7 is the coefficient. Okay? So our goal is to have one variable that has the same coefficient but opposite sign. Then we are going to add the equations to eliminate this variable. The reason we want the opposite sign is because that way we are always going to add. Okay? Then we are going to solve for the remaining variable and then substitute whatever we get for that variable into one of the original equations to find the other variable. Okay, so this is kind of a lot. Let's look at an example here. So I have x plus 7y is equal to 17. X minus y is equal to negative 7. So if you look at both of your variables, everything is lined up. Okay? The equal signs are where they should be. The numbers, the y's, the x's, everything is lined up. So that's step one. Step two is multiply one or both of the equations by a number to result in the same coefficient but opposite sign. So if you look at your x's and your y's, the x's have the same coefficient. Okay, so that coefficient is 1, it's invisible. But we just need the opposite sign. Okay, so I can multiply this bottom equation here by negative 1. And this will give us, so we will have x plus 7y is equal to 17. And then negative x plus y is equal to positive 7. Then we can add the equations. Whenever we do that, we eliminate the x's. So I will have 8y is equal to 24. Then we can divide by 8, and y equals 3. So I have found y, now I just need to find x. So I can plug y into either one of the original equations to solve for x. So I can plug it into the second one because that one looks a little easier. So if I add 3 to both sides, I will get x is equal to negative 4. So my solution as a coordinate point is negative 4, 3. This next example, 3x plus 2y is equal to 22. 5x minus 2y is equal to 42. So again, the first thing we need to do is line up the equation. So everything is lined up where it should be, x's with x's, y's with y's, and everything else. Next, we need to possibly multiply to get the same coefficient but opposite sign. But if you look at your y's here, they have the same coefficient, which is 2, and they have the opposite sign. One is positive and one is negative. So I don't have to multiply by anything. All I have to do is just add the equations together. The y's will cancel, and I get 8x is equal to 64. Divide by 8, x is equal to 8. Okay? So now I can substitute that x into either one of the original equations. So I'm just going to use the first one here. So 3 times 8, that is 24, plus 2y is equal to 22. Subtract 24. You get 2y is equal to negative 2. Divide by 2. And y equals negative 1. So your coordinate point, your solution, is 8, negative 1. So this next one here, We have 7x minus 6y is equal to negative 53, and 2x minus 3y is equal to negative 13. So if you look at your coefficients of your variables, none of them are the same. So we might have to multiply one or both equations by a number to get the same coefficient but opposite sign. If you look, negative 6 and negative 3, those are actually multiples. So I can actually multiply this second equation here by negative 2, and I will get a positive 6y. Okay, so remember, our goal is for the same coefficient but opposite sign. So if I multiply everything by negative 2, I get negative 4x plus 6y is equal to positive 26. Then I can add my equations together. The y's will cancel. Well, 7x minus 4x, that's 3x. Negative 53 plus 26 is negative 27. Divide by 3, and x equals negative 9. I can take this x value and plug it into either one of the original equations to solve for y. So I'm going to plug it into the second one just because it looks a little easier. So I will get negative 18 minus 3y is equal to negative 13. Add 18 to both sides. I will get negative 3y is equal to positive 5. Divide by negative 3. So y is going to equal negative 5/3. So your coordinate point of your solution is negative 9 and negative 5/3. Our last example here, this one is not lined up. Okay, so we have to do a little math, a little algebra to get it to line up like we want it to. So if you look at the top equation, you have x, y, and then your number. So I want my second equation to look like that. So what I'm going to do is I'm actually going to move the 2x over. So what I will get is the first one will stay the same. Then I will have negative 2x plus 7y is equal to 8. Okay? So now look at your coefficients. None of them are the same. None of them are really multiples of each other. So pick a variable to eliminate. So I'm going to eliminate x. So if I look at the coefficients 5 and negative 2, the greatest common factor or greatest common multiple that both of those have in common is 10. So to get the top one to equal 10, I'm going to multiply by 2. To get the bottom one to equal 10, I'm going to multiply by 5. Okay, so I multiply by each coefficient. So I will have 10x minus 12y is equal to 6. And then negative 10x plus 35y is equal to 40. If I add these two together, now I have the same coefficient but opposite sign, so I eliminate the x. Negative 12y plus 35y is 23y is equal to 46. Divide by 23, and y equals 2. I can plug that value into either one of the original equations. So I'm going to do the second one. So I will get 14 is equal to 2x plus 8. Subtract 8 from both sides. You will get 6 is equal to 2x. Divide by 2, and x is equal to 3. So the coordinate point of your solution is going to be 3, 2.